Now this is all about this pressure meter test. Now this dimensions of this pressure meter test, generally the probe size, diameter of probe varying from 44 mm to 70 mm. Then if I say this is L and L0, if this is test cell is L0 and total probe length is L. So, L0 in centimeter, it is varying generally 21 to 36 centimeter. Now, L is varying between 42 to 66 centimeter. So, borehole diameter, borehole you can make it 4 inch to 6 inch. Now, with this the pressure meter test, as I say, you can calculate E and K0, modulus of elasticity and K0. Now, can I do this pressure meter test for all kind of soils? In rock? No. In rock, what will happen? No, it cannot. Either what will happen by means of the philosophy behind it, it will expand, because this test cell will expand, with expansion this soil also expand. That means soil should be, at least soil should be kind of medium to loose, not very stiff kind of soil. So, if it is a stiff or it is rock, what will happen? The test cell, the volume, even if it will expand, it cannot expand this stiff or rock. So, there are limitations also. To overcome this limitation, there is another test, that is called fracture test, hydraulic fracture test, hydraulic fracture test or hydraulic fracture method. In this, you can find K0 E for rock and clay soils. But it cannot be used for cohesion-less soils of greater coefficient of permeability. So, basically the concept is under pressure, under water pressure, piezometer inserted inside the borehole, inserted, it will make a crack in soil or rock. That will give your value of sigma 3. Now, if I draw a schematic picture of this hydraulic fracture test, now this is first you do the casing, first you do the borehole, then you insert the casing, this is casing, then inside casing insert the standpipe with this standpipe by means of a probe or maybe connector by means of probe, insert a piezometer. And this has been connected to water tank or water reservoir. So, by means of pump arrangement, from water reservoir, water pressure is applied to this. Suppose at this point sigma 3 has to be calculated or K0, through piezometer water pressure, all round water pressure is applied. So, once the pressure will increase and at certain point there will be a crack will develop in the soil or in the rock. The moment the crack will develop, the pressure will be released. At that point, that is a point of your sigma 3. If I write this is my ground surface and this is termed as LF, then with this water table this is LW and reservoir is full, here it is called PWI and this is height Y. Then volume V is equal to equivalent volume or height in terms of volume of the water. So, from this a transducer reading, a transducer, pressure transducer is there, pump is there, and at this point pressure transducer is there. Transducer reading you will get it because the moment you apply water reservoir, from water reservoir to water pressure to the soil through this piezometer, the moment you will apply the pressure, what will happen, the transducer will give the reading of this pressure. So, the pressure will increase. How it looks? Somewhere else there is no further pressure, or maybe first start with this pressure, it will increase. At certain point, after certain point there is no more increase, the pressure will remain constant or it may possible that it may decrease. So, by means of double tangent, find it out this fracture or pressure corresponding to your fracture. This is your transducer reading in MV and this is time. So, 1 minute, 2 minute, 3 minute, 4 minute like this, 1, 2, 3, 4. What is the concept here? Suppose this is the piezometer, then this is surrounding soil or maybe rock. Under water pressure, you see, then hydraulic pressure will be developed in the piezometer. Water pressure, water will try to flow. Laterally, all round it will try to flow. Then the pressure will increase. Slowly, slowly what will happen? The soil will be it will be lateral deformation will be there slowly, slowly. The volume change with no volume means by means of pressure, the lateral deformation will be there. At certain point, you are applying pressure by means of water in through this piezometer. So, the pressure is increasing. At certain point, if there is a rock mass, complete rock mass, water inside the void will go, water inside the void of rock will penetrate. So, the pressure will increase. At certain point, the void inside it will become crack. Once there will be a crack, so there will, at what point you will know that crack will be developed in soil or rock. At that point, from pressure transducer you can observe that it will increase, at certain point it remains constant, no more further change in pressure transducer, or it may happen the pressure may fall, it may happen the pressure may fall. So, that point where it remains constant, at that point that is your fracture point, or it relates to your sigma 3. So, you know what is this height, total height, where you are finding out your K0 or E maybe at this point. So, with gamma you can calculate what is your sigma 1. Once you know sigma 1 and sigma 3, you can calculate K0. How do you calculate E? E is nothing but your stress versus strain. So, stress how much applied with this strain, you can find it out E. Now, we will solve one example. Hydraulic fracture method. So, what are the given data? Given data is your length of casing used, which is equal to LW plus V 20.5 feet. Then distance top of casing to ground, which is equal to LF 5.10 feet. Distance LW, it is given 6.62 feet. Saturated unit weight of soil, assuming groundwater level at the ground surface. So, it will be gamma saturated unit weight of soil assuming water table is at ground surface, which is equal to 106.9 Pascal per cubic feet. Why is it water means water reservoir, where you keep this water reservoir with this distance from here, you can find it out y. Y is given 0.87 feet. So, this pressure transducer calibrated as it is given from this pressure transducer, it is coming out to be 1.84, it is this point is coming 1.84 MV. So, pressure transducer calibrated as 0.254 kips per MV. So, now it has been asked find K0, length of the casing used, that means length of the casing means total casing up to here the casing has been made, it is LF, LW plus B, LW plus B is given, distance top of casing to ground, distance top of casing to ground from here to ground LF is given 5 point, LW also it is given 6.62 feet the probe, gamma saturated is given, and water reservoir, the height of the water reservoir from this casing y is given, then find this K0. Now, with this help of this, V is equal to LW plus B minus LW, which is equal to 13.88, pressure because of PWI LW minus Y, LW pressure generated because of water reservoir. So, LW minus Y, this height water reservoir is there. So, pressure height is equal to 5.75 feet. Now, total pressure you can, this is your pressure height, pressure is equal to 5.75 into gamma W, which is equal to 0.0625, which is equal to 0.359 KSF kips per square feet. Now, P0 prime effective overburden pressure calculate. So, P0 you will get it, gamma is equal to, what is your gamma? Gamma is equal to 106.9, 106.9. So, it will be 0.1069, it is Pascal per cubic feet, it has been converted to kips, into 15.40. Where this 15.40 will come into picture? This is the height, total height 15.40 is coming. This is the total height 15.40 is coming. If you take it LW, what is the value of LW? LW is given 6.62 feet, LW plus B is your 20.5 feet, and minus LF, what is your LF? Minus LF, 20.5 minus 5.1, so it will be 15.4. At this height, at this point, you are measuring below the ground surface, you are supposed to measure K0. Now, what is this height? The LW plus B minus LF, this is my height from this ground level. So, it is coming 20.5, 20.5, it will be, it is coming 20.5 minus 5.10, it is coming 15.4. So, this is my gamma, and this is H. So, from there you are going to get 1.646 kibs per square feet. Now, pore water pressure generated or may be developed because of water pressure. So, this will be 13.88 into 0.0625. Probe height, total probe height, this here, from here the water will be there and this will be the water. So, this volume V equivalent to probe height, which is nothing but your 13.88. 13.88 into unit weight of water, this is unit weight of water. So, which is equal to your 0.868 kibs per square feet, and P0 prime is equal to 0.778. This is your effective overburden pressure. I calculate total minus pore water pressure. So, this is effective. With this calibrated, as with this pressure transducer calibration, it is observed that the fracture point observed is 1.84 MV. The calibration is given 2.54 kibs per square feet by MV. That means the pressure will be, fracture pressure is equal to 1.84 into 0.254, which is equal to 0.468 kibs per square feet. Now, with this fracture pressure, so your fracture pressure is given 0.468 kibs per square feet, and PWI water pressure, this is your fracture pressure, this is your water pressure. Water pressure is equal to 0.359. So, total pressure is equal to your 0.827. Kibs per square feet. So, this is nothing but your sigma 3 and this is nothing but your sigma 1. Now, you can easily calculate K0 is equal to sigma 3 by sigma 1, which is equal to 0.827 by your sigma 1 prime, or which is equal to 0.778, which is equal to 1.06. So, if you look at here in hydraulic fracture method, one example is given, details of length of casing pipe and height of this water reservoir Y is given and LW plus V is given. From there you can find it out, height equivalent to your piezometric height you can find, and water pressure you can find it out because of your water reservoir water pressure height. From there water pressure you can find it out, and P0 you can calculate P0 gamma H. Gamma is saturated unit weight, it is given 106 Pascal per cubic feet. It has been converted to kibs per cubic feet, which is 0.1069. This is your saturated unit weight. Now, H from this ground surface, if you look at here, this H is nothing but this, because this is your ground surface. Below this height is your H. Now LW plus B is given and LF is given. LW plus B minus LF, this is your soil height, where you want to find it out K0. From here this H has come from here is 15.4 feet, this is your 15.4 feet, which is coming 1.646 kips per square feet. Now how much effective, because this is water table is at this point, so total minus this pore water pressure, so 13.88 height, this is your height, and unit weight of water. If you look at here, how I calculated, gamma submerged is equal to gamma saturated minus gamma W. So now this will be P0 prime, which is equal to gamma submerged into H, which is equal to gamma saturated into H, this is your P0 minus gamma W into H, this is your U, this is your U. Now this P0 and U, in terms of U I have calculated. So if you look at here, P0 is here calculated and U calculated. So this, if I deduct it from their effective stress, you can get it 0.778. Then another point is given from fracture pressure or maybe pressure transducer. From pressure transducer, this has been given, this graph has been given, with increase in pressure with time, this profile has been given. With this help of graph, with this help of this graph, draw a tangent initial part and draw a tangent bottom part, find it out where the change in pressure. What will happen? Pressure increase, up to certain point it starts either decreasing or it remains constant. So this point is nothing but is your fracture point. So that gives from this graph 1.84 MB. Now this calibration curve, it says 0.254 kips per square feet per MB. So for 1.84 MB, what is your fracture pressure? It is 0.468. This is your fracture pressure generated by water pressure. That means you have to consider water pressure also. So fracture pressure is there, water pressure is your 0.359 kips per square feet. So total you are getting, because of fracture pressure, because of water pressure, 0.827, that is nothing but is your sigma 3. So you know sigma 3, you know sigma 1. So sigma 3 by sigma 1, if you get it, you will find it out your K0, that is your 1.06. Where this K0 has to be used, as I said earlier, this K0 is nothing but earth pressure at rest, earth pressure at rest. Now if you take a soil sample here, say at a height H, this soil sample is there, it has been collected from this ground surface. Now you should know, to simulate in the laboratory, say triaxial test, you should know what is the value of sigma 1 and what is the value of sigma 3. What is the value of sigma 3? So this sigma 1 and sigma 3, if you look at here, the triaxial testing procedures, in triaxial test what will happen? the soil sample placed inside the triaxial chamber. So, initially you apply confining pressure, all round confining pressure of sigma 3. Then after consolidation is over, you apply shearing with increasing value of sigma 1, apply it. So, from where you will get this sigma 3? Sigma 1 I can calculate gamma into H. This is unit weight of soil and this is the height considered to means where the soil has been taken. Sigma 1 you can calculate. Now next parameter, how do I know this sigma 3? Sigma 3 is nothing but if you go that K0 is equal to sigma 3 by sigma 1, then you can find it out sigma 3 is equal to K0 into sigma 1. Now if you know K0, then only you can find it out sigma 3. If you do not know K0, from where you will get it sigma 3? So that means to K0 earth pressure are traced in situ. So that is why this field test is required. Similarly for rock, if it is a soil, suppose there is a rock, similarly for triaxial test, to know the C and phi parameter, to know the phi parameter, soil as well as rock. So you have to go for your triaxial test, you have to find it out what is the overburden pressure sigma 1, also you have to set what is the value of sigma 3. In that case you need to know what is the value of K0. If you have your test, field test, if you know the K0, then you can find it out easily what is the value of sigma 3. Now let us say this is my ground profile, ground surface. Or I can draw once again this ground surface. Let us say this is layer 1, layer 2, layer 3, layer 4. Now a footing has to be constructed or rested in the soil profile. So I do not know where this footing to be placed. You have to calculate the strength parameter of each layer, C phi, C1 phi 1, C2 phi 2, C3 phi 3, C4 phi 4. Now for each layer by means of boring you have collected undisturbed sample at this middle of this you collected undisturbed samples. Now for each layer you know what is the value of sigma 1, then what is the value of sigma 2, then what is the value of sigma 3, then what is the value of sigma 4. What I mean, if you do not do K0, if you do not do hydraulic fracture test or maybe pressure meter test, you cannot find it out K0. So once you know the K0 value of each layer, so layer 1 K01 is this, layer 2 K02 is equal to this, K03 is equal to this, K04 is equal to this. Once you know K0 value for each layer, then with known value of sigma 1, sigma 2, sigma 3 and sigma 4, you can easily calculate what is the value of sigma 3 here, sigma 3 here, sigma 3 here, sigma 3 here. Once you know the sigma 3, then whatever the soil sample you collect from the field at this point, suppose say this is the soil sample at this point, say A, B, C and D, then easily you can conduct triaxial test in the laboratory to find it out the parameter C and phi, C1 phi 1, C2 phi 2, C3 phi 3, C4 phi 4. So this is basically the requirement, directly this requirement for field explorations, maybe to know the engineering properties and it has advantage that you will get whatever the K0 value, that to be in the in situ conditions without disturbing the soil sample inside the ground, you are finding the K0 value. Then once you get K0 value, rest problem will be solved. So, these are the two methods, hydraulic fracture as well as pressure meter method. Generally in India, pressure meter method has been applied, means widely used, but hydraulic fracture method has been used where this rock mass is there, because pressure meter you cannot do this test in rock mass. This hydraulic fracture method has been used.